So far we have seen the algorithm and pseudocode behind the insertion sorting algorithm, right? Now let's quickly implement the same thing using the C++. So here inside the sorting folder inside our project, so here let me just create one file called insertion sort.cpp. Okay, and let me just minimize the side navigation. Here let me import the C++ basic boilerplate that we will be needing. Along with this, let me just also include the vector so that we can use that for passing a array of values. Okay, now here let me just write our own insertion sorting class. Okay, here let me just add a public method, and this method signature will be in the end whatever the function that we are writing for sorting the given array of values in the ascending order or descending order, right? It needs to return the sorted array in the end. That's the reason why return type is vector of type int, and let me just name the function as insertion sorting. This function will basically take the integer values in a variable arr. Now we need to sort these array of values in the ascending order in this specific function using the insertion sorting algorithm. If you remember the pseudocode that I have given earlier, right? In the case of insertion sorting algorithm, what we will do, we will assume that there are two parts of array in which one part is entirely sorted and the other part is entirely non-sorted. Our aim is to take the value from the non-sorted part so that we can move that value into appropriate position of the sorted part. As a result, the sorted part length will increase. By repeating the same logic, in the end we will basically get the entire array sorted. But when we are beginning, right, there are no two parts in the array. But if you observe the array carefully, we can assume the elements till 0th index as sorted part, and from index 1 till the end of the array we can assume it as a non-sorted array. So our aim is to run the logic for picking up the values from index 1 till the end to move it on to the appropriate position. For that, what I will do is I will write one for loop. This for loop will basically be starting from index 1 and it needs to run for all the values. That's the reason why as long as I is less than the size of the vector that we are getting, and in each and every step I just want to increment it by 1. Now what we need to do, the value that we need to compare and move is available at ith index, right? For that, let me just define couple of helper variables that we would be needing. Let me just define one variable called temp index. That index is nothing but I, because the value that we need to move to the appropriate position in the sorted part of the array is at ith index. Okay, and the value at the temp index is nothing but temp index value equal to the value at ith index in the array of values that we are getting. Now what we need to do, we need to compare this value with the values we have on the sorted part of the array. For that, what I will do is I will simply be running a loop as long as this temp index that we have, if it is greater than 0, and along with this what we need to do, we need to compare the value temp index value. If at all the temp index value is, if it is less than the value at the temp index minus 1th position, that means whatever the value we have at the temp index minus 1th position, it is greater than the value we have at the temp index. Since it is a smaller value, this value needs to come first and the larger value needs to come after that. That's the reason why what we will do is we will simply move the temp index minus 1th value to the temp index position. That means we are simply moving the element to right by 1 position. So what we will do, array of temp index is equal to array of temp index minus 1. Okay, we have successfully moved the value at temp index minus 1th position to the temp index position. Now we are not done yet, right? there could be further more values on the sorted part of the array which we still need to compare for the appropriate position for this temp index value. To continue the same logic, what I will do is I will simply do temp index equal to temp index minus 1. By doing so, the same logic will run, and if at all the value at the temp index minus 1th position is greater, it will shift that element to right by 1 position till we find the appropriate position for the temp index value. Once we are done with this while loop, right, the appropriate position for the value is available inside this temp index. All we need to do is we need to move the value at the temp index value to this temp index position. So what I will do is array of temp index is equal to temp index value. Okay, so that's all we need to do here. Remember, the entire idea behind insertion sorting algorithm is picking up the value from unsorted part so that we can find the appropriate position for that in the sorted part, and we need to insert it. For finding that appropriate position, what we will do is in the sorted part of the array, from right to the left, we'll start comparing all the values greater than the value that needs to be moved will be shifted to right by 1 position, so that in the end we can move that value to its appropriate position in the sorted part of the array. By repeating the same logic, what happens as we are moving all the values from the unsorted part of the array into sorted part of the array, sorted part will basically increase. In the end, we will basically run out of all the unsorted elements. Okay, once we complete this outer for loop, we just need to return the sorted array, which is nothing but whatever the variable that we have got itself. If you observe the same here, just like selection sorting, bubble sorting algorithm, insertion sorting algorithm is also one of the in-place sorting algorithm. We have created couple of the temporary variables, but we have used the input array that we have got itself for sorting the entire array in the ascending order. So it is one of the in-place sorting algorithms as well. Okay, here let me just add the semicolon for the class closure. Now we have successfully implemented the insertion sorting for sorting the array of values in the ascending order. All we need to do is call this function and see if it is actually sorting the values in the ascending order or not. First, let me just define a vector of values. Let's just say I want to store 12, 3, 2, minus 10, minus 11. These are the values I want to sort in the ascending order. Now here I think I have given full stop. That's the reason why we are getting that error. Anyway, I need to give the comma. Now to call this insertion sorting function, we need to create the object of this insertion sorting class, right? So first let me just initialize that class is. From this is reference, let's just call the insertion sorting function and let's just pass the array of values that we have created. In the end, this function will basically sort the array in the ascending order and it will return, right? And let's just store it in some other variable, result array. And here we need to run a for loop and we need to print, right? And we have done that already in the case of bubble sorting logic as well. So let me just grab that logic for printing the values so that we can use it here as well. So let me just paste it here. So all the variable names are also matching. As a result, we are not seeing anything. Now let's just try to run this file and see if it is actually sort the values in the ascending order using the insertion sorting logic. So if I just choose the run code option, see, if you observe here, whatever the values that we have given, right, they are sorted in the ascending order. Minus 11 is the smallest value, next is minus 10, 2, 3 and 12. If at all, if you want to add couple of more values, let's just say minus 100, 199, 89, 23, minus 20, anything, whatever the values that you want to sort, you can sort using the same logic. Okay, you see, we have got the entire array sorted in the end. Okay, so this is the function for implementing the insertion sorting for sorting the array of values in the ascending order. If at all, if we want to implement the same for descending order, right, all we need to do is just copy paste the function and modify the function name to descending order. Here the entire logic will remain same. The only modification that we will need to do is change this less than operation to greater than operation. So that's the only modification, just like what we have done in the case of bubble sorting and selection sorting as well. The entire logic will remain same. So if I have to validate this, let me just copy that function name and paste it here. Now this entire array of values needs to be sorted in the descending order. So to check that, let me just run the code. Okay. So if you observe the output that we have got here, all the values in the array are sorted in the descending order. Okay. So that basically completes the validation of insertion sorting algorithm for sorting the array of values in both ascending order and descending order. Okay, so that's all there is for implementing the insertion sorting algorithms. Thanks for watching this one. In the next video, we will get started with the merge sorting algorithm.